So question 6a, we are given a thin hemispherical clear plastic bowl, radius 55 cm. We place it in a tank that filled with water. The refractive index of water is 1.33. The base of the bowl is sink to a depth of 8 cm and the water level rise to a height of 308 cm. So we place an object at the bottom of the tank and is viewed vertically from above the bowl. So we need to calculate the image distance from the base of the bowl. Is the image virtual or real? We need to justify the answer. So this will be the image formed due to the refraction at a spherical surface. So we are going to use equation 68 in our list of formula. So anyhow, which one will be our N1, which one will be our N2? So always bear in mind, N1 will be the medium where we have object located. So our object is put inside the water, so our refractive index for N1 will be 1.33. Then how far is the object from this spherical surface? So the object distance will be 308 minus 8 centimeters, so the object distance will be 300 centimeters. So another medium will be A1, the refractive index is 1. So we put in the radius as well. The radius is 55 centimeters. Anyhow, what is the sign convention for radius? R. So we have to bear in mind, our R will be given a positive sign if this is a convex surface and negative sign if this is a concave surface. So by seeing from the object, you can see clearly as the light strikes on the surface is convex. So it should have a positive sign. Then we do our calculation, we will get our V will be negative 95.847 centimeters. So refer to the value of V given, refer to the value of V calculated. Our V value is negative, so the image is virtual. Okay, the reason is the V is negative, whereby it's showing us that the image will be formed same side as the object. So this is the mark allocated for the questions. 4 mark is given. Proceed to question 6b. We have an object. We place 14 cm from a diverging lens of refractive index 1.5. So the refractive index of the material for the lens is 1.5. And this lens have the radius of curvature 4 cm and 7 cm respectively. So we need to calculate the focal length of the diverging lens and the image distance. So this is the two equations we are going to use. In order to find the focal length of the diverging lens, we are going to use equation 69, the Lens-Macker equations. Anyhow, how I'm going to determine that my R1 is 4 cm and my R2 is 7 cm? So we refer to the radius of curvature. We refer to the curvature of the surface given in the figure. We can see very obviously the radius of curvature for the first surface is smaller than the radius of curvature for second surface. That's why our R1 will be 4 cm, our R2 is 7 cm. Why we have negative sign for both R1 and R2? This is how we determine the sign convention for the R. Seen from the object. So when you see from the object, you can see very obviously R1 will be concave surface. R2 also is concave surface. So we should put a negative sign for both of R1 and R2. Then we put in the value into the Lens-Macker equations, then we solve it, we will get the focal length is negative 18.67 cm. Proceed to the second question. In order to calculate image distance, we are going to use equation 66. So we have 1 over f is 1 over u plus 1 over v. So substitute the value for the focal length that you already calculate from question B1, and then the object distance is 14 and it should be positive because we always have the object put in front of the lens, so it's a real object, so its u is positive. Then we get our v, the image distance is negative 8 cm. So the negative sign telling you that the image form is virtual. This is the mark allocated for question 2.